This lesson moves us forward and we start to look at scale statements and how to simplify them into some forms using our calculator, and then to use cross multiplication to actually figure out some of the dimensions in a drawing or on an original diagram using these scale statements. So we're going to look at it just through one simple example right now. And it says on a blueprint, 1/4 inch is equal to 1 foot. Write this as a scale statement in the form 1 to x. So we got 1/4 inch, 1 foot, and at the end it wants us to be 1 to x. Now if you think back to our other lessons that we did during this unit so far, just the first one, I mentioned that we're always going to be talking about this as drawing to original. So I always say, what is it in the drawing and what does that actually turn out to in the original? This is how a scale statement works. So it's saying on a blueprint, 1/4 inch is equal to a foot in reality. So this is my drawing, this is my original. So Dr. Orr. So if I was to draw this, this is 1/4, every 1/4 of an inch is 1 foot in actuality. Now we want to have this probably 1 foot, you should remember from grade 10, is the same thing as 12 inches. So we're going to say 1/4 inch is the same thing as 12 inches, 12 inches being a foot. Now that is a scale statement, or we could even write this, because with the fraction I could say this is 1/4 inch to 12 inches. Remember that 1/4 as a decimal is just 0.25. So this is a good scale statement, except it does ask us when we look at this that we want the first number to be a 1. Now there's a few ways that we can look at this. One way from a purely mathematical standpoint is to say, well, if I need that top number to be a 1, I have to consider what do I multiply by 1/4 to get that to equal to 1, so this top number. So you have to know your math skills pretty well and say, well, 1/4 times 4 equals 1. And we could prove that on our calculator. 1/4 times 4 equals 1. So if I times that by 4, I get 1. But in a fraction, what I do at the top, I have to do the bottom, or a ratio. So I got 1 to 48. So the proper way to write this in the form, it's saying write it in 1 to x, would be 1 to 48. So that says every inch in my drawing is actually 48 inches, or 4 feet, in the original plan or the original document. So that's one way, using just some knowledge about math. Another way, if I was to look at this and I could say 0.25 over 12. If you have a good calculator with some fractions available to it, so this is a graphing calculator, I can choose math, frac, and say, hey, can you convert this to lowest terms? I get the 148 here as well, 1 to 48. So if you have a graphing calculator, you can convert it. If you have a scientific calculator with a fraction button, you can put the fraction in and hit enter, and you're still going to get the 1 to 48. So now the question moves a little bit on. It says, in this diagram or this blueprint, it's saying the actual length, what is the actual length of a room if on the blueprint we have 3 3/4 inches? So what we probably want to do, 3 3/4, we want to know as a decimal, well, that's 3.75, because 3/4, 3 divided by 4 is 0.75. So 3.75 inches on the blueprint. They're saying, what's the actual length? So you got a picture, it's 3 3/4 inches long, and if I was to build this, how long would that room be? So we can still go drawing to original, which we just figured out our scale is 1 to 48. 1 inch in the drawing is 48 inches in the actual room. So I can make a proportion again, like we did in our other lesson, and say, okay, the drawing's on top. So this 3.75 is on the drawing. That's why it goes on top. And I'm trying to figure out, in actuality, what would that be? So this is where we use our skills of cross multiplication again. We could draw this. We look at the line that actually has 2 numbers on both ends, and that's our multiplication. 3.75 multiplied by 48. and then you divide by the only number on the other stick, which in this case is 1, which won't make a difference, but that would tell me my unknown. So if I was to crunch these numbers out in our calculator, I'm going to get 180, and in this case we're talking inches. So from the blueprint that was only 3 3/4 inches long, the actual room would be 180 inches long. Now 180 inches probably doesn't mean, you might have a hard time visualizing that, but if you do remember that 180 inches, there's 12 inches to each foot. So if I was to divide these out, 180 divided by 12, well, that would mean this room would be 15 feet long. Either one of these answers in this case is acceptable because it doesn't ask you to be in inches or feet. But this room is 15 feet long or 180 inches long. I do want to take this opportunity to look at this just a little different way, because we converted this in the original question to a 1 to 48, because the question asked us to do that here. It says make sure that that drawing number is a 1. If we would have just kept this, the 0.25 to 12, this would still give us the answer at the end. So if I was to look and say, okay, I couldn't get that first question, but I know the drawing to original is 0.25 over 12. So every 1/4 of an inch is 12 inches in reality. If I was to do the same thing here and say, okay, so now there's 3.75 on the drawing, what is this room going to be? If I was to use this because I couldn't convert to that 1 to 48, I still did this and said 12 times 3.75 and then divide by that 1/4. And I'll show you on the calculator. I'm going to say 12 multiplied by 3.75 divided by 0.25. I still get 180 inches. So even though we might not have been able to get that first part in the question to get it to be 1 to 48, if you're stumped there, we can still get the second part of the question by using just the drawing to original with the numbers they gave us. So just know there are 2 options here to find that final answer.